Hello students, let's do geometry. Lines and angles, exercise 16A. Exercise 16A is on page number 187. We are beginning with question 1. State true or false. The first statement is, a line segment 4 centimeters long can have only 2000 points in it. This statement is false because a line segment, whatever the length is, can have an infinite number of points in it. So you can't give it a number and say it has only 2000. It has an infinite number of points on it. So let's write this statement as false. Question 2. A ray has one endpoint and a line segment has two endpoints. Okay, so let's draw a ray. Now suppose I draw a ray. Now this end goes on endlessly and this end is fixed. That means a ray has one endpoint. That part of the statement is true. Now here it says a line segment. So let me draw a line segment. This is a line segment. It has two endpoints. As you can see, the line segment does not have any arrowhead. An arrowhead will tell us that the line goes on endlessly at that end. Now here there are no arrowheads. That means there are two fixed points and these are two endpoints. So this statement which says a ray has one endpoint is true and a line segment has two endpoints is also true. So this statement is true. Question 3. A line segment is the shortest distance between any two given points. So let's draw 2 points, any 2 points. Now what is the line that we draw through this? This is a line segment. The line that we have drawn between these two given points is the shortest distance. So this statement is true that is a line segment. So let's write that statement as true. Question 4. An infinite number of straight lines can be drawn through a given point. Now suppose you have one point. How many lines can you draw through it? Let's see. Let's begin and see. Okay. So let's put a point here and now let's draw. Okay, we've drawn one line. We've drawn another line. We have another line. We have another line. See, we can draw many lines, isn't it? So an infinite number of lines. This statement says that an infinite number of straight lines can be drawn through a given point, and that statement is true. So let's write that as true. So we finished with true and false. Now let's begin question 5, which says, write the number of endpoints in A, a line segment AB, B, a ray AB, and C, a line AB. Okay, now let's take this line itself as a line segment. Let's name it as AB. Now suppose this is a line segment and I name it as AB. As you can see, there is an endpoint here and an endpoint here. So a line segment will have two endpoints. So this line segment AB has two endpoints. Now question B says, a ray AB. Now let's take this as the ray. If this is the ray, then there should be an arrowhead at one end. So let's put an arrowhead here. Now if this is the ray, then it has an arrowhead at one end and the other end is fixed. So this is the fixed point. So let's name this as AB. So this is AB ray, ray AB. And one end there is an arrowhead to show that that ray goes on endlessly and the other end is fixed. So there is only one endpoint in a ray. So the answer here is 1. Now let's go on to question C. How many endpoints are there in a line AB? Now suppose this is a line. Now I'll just put 2 points here to name it AB. But as you can see, this is a line. So that means this will go on endlessly on both sides. A line is like that. It will keep moving. So on the end B, it will continue. End A, it will continue. So a line will not have any endpoints. So there are no endpoints. So what can we write there? How many endpoints does it have? 0. It doesn't have any endpoints. Question 6. Out of all these given to us, that is AB is a line because there are two arrowheads. The other AB is a ray because there's one arrowhead. This AB is also a ray. You can see the arrowhead. And this is a line. So we have a line, ray, ray and line segment. This is a line segment because there are no arrowheads. That means the two ends are fixed. So this is a line, ray, ray, and a line segment. Out of these, which one has a fixed length? Now this line AB, because of the two arrowheads, it will keep moving, so it doesn't have a fixed length. The ray will keep moving to this side, so there's no fixed length. This ray will keep moving to the other side, so there's no fixed length. Whereas AB is a line segment, it has a fixed length. So what is our answer? A, B, and this is a line segment. This symbol on top shows that it's a line segment which has two end points. Question 6. How many rays can be drawn through a fixed point O? So just like we did in the previous question, if you have a point and if you have to draw through this, you can draw a number of rays. So you can draw a number of rays. If you have a fixed point, through that you can draw an infinite number of rays. So what is our answer here? Infinite. The answer is infinite. That means many, countless. Next question. How many lines can be drawn through three collinear points? Now what are collinear points? Collinear points are three or more points which lie on the same straight line. Now suppose I have 3 points here and there is a line passing through all these 3 points. If I name them A, B and C, they are called collinear points. Okay, so the question here is how many lines can be drawn through three collinear points? So we have three collinear points. How many lines can you draw? You can only draw one line. Okay, so the answer here is 1. Then, what are non-collinear points? Non-collinear points are 3 points that don't lie on the same straight line. You can see here, suppose I name this as A, B and C. These are 3 non-collinear points because they are not lying on one line. So through this, how many lines can you draw? I can draw one line like this, one like this and one like this. That means I can draw 3 lines. So as you can see, we can draw 1, 2 and 3 lines through 3 non-collinear points. So the answer here is 3. Question 9. Is 40 degrees the complement of 60 degrees? Now what are complementary and supplementary angles? Two angles that add up to 90 degrees are called complementary angles. So I have 60 degree already given to me. Now the question is 40 degrees the complement of 60? Now 60 plus 40 should give me 90. Does it give me 90? 60 plus 40 is 100. So it's not equal to 90 degrees, isn't it? It's not equal. That means 40 degree is not the complement of 60 degrees. So the answer is no. Next question, is 45 degrees the supplement of 45 degrees? So supplement means two angles must add up to 180 degrees. Now 45 plus 45 will add up to only 90 degrees. It's not adding up to 180 degrees. So 45 degrees is not the supplement of this 45 degrees. So the answer here also is no. Question 2. In which of the following figures are angle AOB and angle AOC adjacent angles? Give in each case reason for your answer. So here we have two angles AOB and AOC. Let's see that AOB and AOC. So let's mark them. So AOB, this is the angle that is marked in red. This is angle AOB. Now angle AOC is the angle that is marked in blue including the red portion. So that is the bigger angle. AOC is the bigger angle and AOB is only that red portion which is a smaller angle. Now the question is, are these adjacent angles? Now what are adjacent angles? Adjacent angles are two angles that have a common vertex, a common arm and the other arms are on the opposite sides of the common arm. Now let's go slowly. Now they are angles that have a common vertex. What is a vertex? This is a point where the two angles meet. Okay. Now the point where the two rays meet to form an angle is called the vertex. So this is the point O. The point O is called the vertex. Now let's write down for angle AOB, which is the vertex for angle AOB. it is O. Now for angle AOC, also the vertex is O. So let's write that down. So now both these angles have a common vertex, same vertex. They share one vertex. So that means according to the properties of adjacent angles, one property is correct. That means they share a common vertex. Next thing is they share a common arm. So let's write down the arms of angle AOB and angle AOC. Now what are the arms? Now if I draw an angle like this, and I name it as O, A and O and B here. Now OA, this is one arm and this is the other arm. So there are two arms for an angle. So now let's see in the figure given which is the arm for angle AOB. Starting from O, OA is one arm and OB is the other arm. Let's write that down. So we have them there, OA and OB. Now similarly, let's find the arms of angle AOC. Let's write it down, angle AOC. What are the arms? Again, here we have OA and OC. So let's write that down, OA and OC. Now there is one arm that is common to both. As you can see, we have OA for this angle and OA here also. That means this arm OA is common to this angle, the red angle, and it's common to the blue angle. So the second property of adjacent angles is that they should have a common arm. So they have a common arm. But there's a third property which says that this common arm should be in the middle. That means the other arm should be in the opposite side of the common arm. So OA is right here. If this is to be in the middle, it should have come here somewhere, isn't it? So now OA is here, OB is here, and OC is also on the same side. It should have been on the opposite side. So the third property which says that in an adjacent angles, the other arms of the angle should be on the opposite side of the common arm is not true here. So in that case, angle AOB and angle AOC are not adjacent angles. Let's write it down. Angle AOB and angle AOC are not adjacent angles. Now here they're saying give a reason for your answer. The reason is as the other arms of the two angles do not lie on the opposite sides of the common arm OA. So OA is here. Now this should have been in the middle. Then we can say the other two arms are on the opposite sides. So now it's not on the opposite sides. Question 2. Here also we have angles AOB here and angle AOC. Okay, so let's mark those angles. So what we have marked in red is angle AOB. Now first let's take only angle AOB, and write the vertex. Which is the vertex for angle AOB? O. The vertex is the point where the two rays meet. So the vertex is O. Now let's write the arms for angle AOB. What are the arms? The arms are OA and OB. So let's write that down. OA and OB. Okay. Now let's look at angle AOC. AOC is here. That is only that small portion in blue. That is angle AOC. Now let's find the vertex for angle AOC. The vertex, as you can see, is O. This is AOC and the vertex is O. So let's write it down. Now let's write down the arms for angle AOC. The arms are AOC, OA and OC. So let's write that down. OA and OC. OA and OC. Okay, so now let's see if they follow the properties of adjacent angles. Adjacent angles have a common vertex. So this is correct. So they have a common vertex. So this part is correct. Then adjacent angles have a common arm. See OA and OA. See OA is common to both these angles. So they have a common arm also. So that is also correct. Now, but is this common arm OA on the opposite sides? The other arms, are they on the opposite sides of this arm? That means OA should be in between the other two arms. But it is not in between. It is in this end. Okay, so that means the other two arms are not on the opposite sides of A. So these two angles are not adjacent angles. Angle AOB and angle AOC are not adjacent angles, and what is the reason? As the other arms of the two angles do not lie on the opposite sides of the common arm OA. Question 3, here also we have angle AOB and angle AOC. Now let's write the vertex of angle AOB. The vertex is O. Now angle AOC also the vertex is O. Now let's write on the arms of angle AOB. Now the angle in red is angle AOB. What are the arms? OA and OB. Let's write it down. The arms are OA and OB. Now let's look at angle AOC. What are the arms? OA and OC. Let's write it down. Angle AOC. The arms are OA and OC. Okay, so now let's look at this. Now here the vertex is common. Here there's one arm that's common to both. Now there's one more thing that we need to see. Is this common arm in between the other two arms? Yes. Can you see that? OA is in between OB and OC. That means OB and OC lie on the opposite sides of the common arm. That means angle AOB and angle AOC are adjacent angles. So we have written that down. Angle AOB and angle AOC are adjacent angles. What is the reason? As the other arms of the two angles lie on the opposite sides of the common arm OA. Question 4. So here also we have angle AOB and angle AOC. So let's mark that. The angle in red is angle AOB and the angle in blue is angle AOC. This whole thing, including the red portion, is angle AOC. Now let's write the vertex, angle AOB, which is the point that the two rays meet O. The two rays OA and OB are meeting at this point O. So the vertex is O. Now for angle AOC also, which is the vertex is O. Now let's write the arms of angle AOB. What are the arms of angle AOB? OA and OB. Let's write it. OA and OB are the arms. Now for the other angle AOC, what are the arms? So these are the arms. This is a point in the middle, and from here you have one line and from here you have another line. These are the two arms. So what are the two arms of angle AOC? OA and OC. So let's write that down. OA and OC. So here also they have a common vertex, they have a common arm, but is this common arm in between the other two arms? So OA is the common arm, but is that coming in between the other two arms? No. We have one arm here and the other arm on the same side. It should have come to the opposite side. But since it's on the same side here, these two angles are not adjacent angles. So let's write that. Angle AOB and angle AOC are not adjacent angles. And what is the reason? As the other arms of the two angles do not lie on the opposite sides of the common arm OA. So these two angles are not adjacent angles. Question 3. In the given figure, AOC is a straight line. Let's see. AOC. Yes, as you can see, it forms a straight line. Now find, question 1 is x. Find x. This is given to us. We need to find x. Then we have to find angle AOB. That is this angle, angle AOB. And then angle BOC, which is this angle, angle BOC. So now first thing we need to do is find x. Now let's use the property AOC is a straight line. Now, and when you have a straight line, the angles that are formed on the straight line are equal to 180. And here we have two angles that are equal to 180. So they are called a linear pair. That is, angle AOB and angle COB are a linear pair. That is, the sum of the angles will be equal to 180 degrees. So what is angle AOB? This is angle AOB. What is the measure? X plus 25. That means x plus 25 plus COB, that is 3x plus 15, should be equal to 180. So let's write that. Angle AOB plus angle COB should be equal to 180 degrees. And let's substitute for angle AOB. We have x plus 25 degrees, that is angle AOB, plus angle COB is 3x plus 15 degrees. Both this should be equal to 180 degrees. So now we have a linear equation. So let's try and solve and find the value for x. So here I have x, that is 1x, and here I have 3x. So 1x plus 3x will make it 4x. 4x plus, now here I have 25 degrees and here I have 15 degrees plus 15. So 25 plus 15 is 40. 40 degrees. This is equal to 180 degrees. Now let's keep only 4x on the left hand side. 4x, and on the right hand side we already have 180 degrees. Now I'm going to move this 40 degrees from the left hand side to the right hand side. So that becomes minus 40 degrees. Plus becomes minus. So now what is the value of 4x? 4x is equal to 180 minus 40, which is 140 degrees. So now we can find the value of x. X will be 140 degrees. Now what is this 4x here? 4x is 4 into x. So I'm going to move the 4 alone to the other side because it's into or multiplication. When it goes to the other side, it becomes division. 140 divided by 4. So let's do that division. Let's divide 140 by 4 and see what we get. Let's take 14. 4 3s are 12 minus 2, 0, 20. 4 5s are 20 minus 0. So we have 35. So x is equal to 35 degrees. So we have found the value of x. X is 35 degrees. So this is our first answer. X is equal to 35 degrees. Now we have to find angle AOB with the same figure. We should find the value of angle AOB. So let's do that. Now we need to find angle AOB and angle BOC. So angle AOB is this. It's already given to us as x plus 25 angle AOB. So let's write that down. Angle AOB is x plus 25 degrees. And x we just found out to be 35 degrees. So this is 35 plus 25 degrees. So 35 plus 25 is 60. So angle AOB is 60 degrees. So we found our answer. Angle AOB is 60 degrees. Now let's find angle BOC. Angle BOC is this angle BOC, which is 3x plus 15. So let's write that down. 3x plus 15 degrees. So 3x means 3 into x. So x is 35 degrees. 3 into 35 degrees plus 15 degrees. So how much is 3 into 35? 3 into 35 is 105 degrees. Now add 15 degrees to this. 105 plus 15 is 120 degrees. So we found the value of angle AOB to be 60 and the value of angle BOC to be 120 degrees. So this is angle BOC. Question 4. Find y in the given figure. So we've been given a figure, and where is y? We have y here. Now we need to find the value of y. Now AOC is a straight line. As you can see, AOC and the sum of angles on a straight line will always be equal to 180. Now we can see three angles here. Y, 150 degrees minus x, and x. So the sum of all three angles will be equal to 180 degrees. So let's take AOB as the first angle. So that is angle AOB plus, now let's take the second angle, angle BOD. Okay, so that is angle BOD plus the third angle, that is angle DOC. Angle DOC. All this should be equal to 180 degrees. Now how much is angle AOB? That is y, isn't it? So let's write that as y plus, how much is angle BOD? BOD is 150 minus x. So that is 150 degrees minus x plus how much is DOC? DOC is x. So that is x. Totally this should add up to 180 degrees. So here let's open the brackets here. Now now when you have a plus sign before the bracket, there won't be any change in the sign of whatever's inside the brackets. So that will be plus 115 without a change minus x, also no change. Then we write the rest, that is x is equal to 180 degrees. Now here we need to find the value of y, isn't it? So before that, let's solve or simplify whatever's inside. Now if you look at this, minus x and plus x, minus x plus x is equal to 0. So they will get cancelled. So here we only have y plus 150 degrees is equal to 180 degrees. This has become a linear equation. So now we can solve and find the value of y. Y is equal to 180 degrees. Now I'm going to transpose this from the left hand side to the right. So plus 150 will now become minus 150 degrees. So now we can find the value of y. Y is equal to 180 degrees minus 150 degrees, which is 30 degrees. So we have found the value of y. So we will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.